Welcome to a tutorial in ETABS. This is the tutorial problem we will be working through. After opening ETABS, we want to create a new model. You can select built-in settings and you can change to metric if you would like. For this case, we will just use the default settings. First thing we want to do is create our grid space. In this case, beam width was defined as 15 in the tutorial problem. For number of stories, we will just do 1. Since we aren't doing an actual structure, we're doing a simply supported beam. You can change story height for your columns when you do the assignment problem. Make sure grid only is selected, click OK. So we're doing a simply supported beam. We don't need this 3D view. First thing we want to do is change the view of our model. Go to View, Set Elevation View, and click Apply. Click OK. This will give us a side view of our model. The next thing we want to do is define materials. Go to Define, Material Properties. There's some preset materials here that you can use. You can also add a new material and create different types of materials here with different types of strength. In this case, we're going to use the 4000 PSI and the grade 60 steel. Next thing we want to do is define our section properties. So we will go to Define, Section Properties. We will create a frame section. We want to add a new property. We want to add a concrete rectangular beam. You can name the beam. You can select the materials that we previously defined. In this case, we'll use 4000 PSI. You can change the color. For the problem, our depth and our width are 12 inches. So we want to do is set up our rebar, our reinforcement. We will go to Modify/Show Rebar. Here we want to do 2 bars on top, 2 bars on bottom. We want our top longitudinal bars to be number 7, and actually here number 9, and then here will be number 7. And then stirrups you can just set as number 3. Click OK. Click OK. Next thing we want to do is draw our beam. You can come over to this icon on the left here, Draw Beam/Column. Make sure under Properties of Object, you have selected the section that we just created, in this case, FSEC1. Go to the model, click on your first point, click on your second point to draw the beam, hit Escape to deselect. Next thing we want to do is apply the supports to this simply supported beam. Go to Assign, Joints, Restraints. First thing we want to do is apply a roller. We will go to our model. You will select a point, select the roller, click Apply. Select the next point, click the pin, click Apply. Go ahead and click OK or Close. Next thing we want to do is define our loads. So we'll go to Define, Load Patterns. We want to create a new load pattern that includes the self-weight is included. You can name it whatever you want. Make sure that self-weight multiplier is set to 1. This will include the self-weight. Click Add New Load. This is technically a live load, so we want to make sure it's set as live and then make sure this is included. So in this case, we'll do 2, Add New Load. And this is the load that we will use. Click OK. Now we want to assign this load to our beam. We'll do Assign, Frame, Frame Loads, Distributed Load. Here we want to select the load pattern that we created. And then we want to add in the force for the problem, 5 kips per foot. We go to our model, select the beam, click Apply, click OK. Our distributed load has been applied to the model. Next thing we want to do is begin analyzing the structure. We will click Analyze. First thing is to check the model. select/deselect all, make sure that is clicked. All these will be checked off. Click OK. No warnings, excellent. Next we want to do is analyze the actual structure and run the analysis. You can click F5 or click Run Analysis. Make sure you save a folder. The analysis will run. It takes a minute. Click Done. You can see the deflection in our beam. A couple of things you can do. You can display the diagrams by clicking Display, Force/Test Diagrams, Frame and Pier. Here you can apply different views to this model, such as shear. So click Shear, click Apply. You can see the shear deflection. You can also show your moment diagram here. And then another thing, make sure that this is selected to your load, case 2. This will show the correct shear and moment for our diagrams. To print the report, you click File. You can either create a report, this will give a report with tables and all the data included. You can also print your graphics by going File, Print Graphics. This will give you a nice PDF of your moment or shear diagram, depending on which one you have selected. Thank you so much.